Okay, so today I'm going to be going over the chromatic dispersion problem, number 1. So the problem states, a given spectrometer uses a flint glass equilateral prism. White light is directed into the prism as shown below on an angle of 43 degrees to the normal dotted line. The light is dispersed into the visible spectrum. At what angle to the normal does the red light leave the prism? The index of refraction for red light in flint glass is 1.662. So that was the angle I was given in the problem. Obviously, just input yours when you're going through it. So, things to know to solve this problem. First, you know Snell's law. Again, Snell's law I illustrated here, showing that our angle that we're starting with is going to be this, and then our angle that comes out, which we'll find out will be on the opposite side of the normal. We also need to remember the rules for triangles. So, as you can see here, angle A, B, and C added together would be 180. So, to solve this problem, we need to set up some key points. First, we need to set up our prism correctly. We know from the start of the problem that we have an angle of 43 going in. Using Snell's law, we can find that angle on the opposite side and get how the ray of light is going to pass through, or the red ray of light is going to pass through our prism. The way we find that first theta is, again, Snell's law, which we can calculate through here. So again, I found it to be 24.22. And then once we have that, we can know from our normals that's given to us in the problem that we can formulate a triangle that will equal 180 degrees total. So using our laws of triangles, we can find out what our theta 3 is here and where essentially the red ray of light is going to be exiting our prism. So again, using Snell's law, we can figure out what the problem is asking us, or our theta 4. And again, using the same thing, just remembering that now our n values is going to be the 1.66 sine 35, which we found to be this angle right here, to finally give us a problem of 77.0316, which is going to be this theta here. So again, essentially, we're using Snell's law to figure out the theta. We're establishing our triangle inside the prism from the red light ray, and then using that, again, we're using Snell's law to figure out how it's exiting the prism. Additional information for question 2 is, again, you're going to be doing the same thing, but for green light, which has a little bit different theta and index for refraction. So once you do that same steps that we did for question 1, you're going to do it for question 2. You just subtract your new theta 4 from the theta 4 that you had before, and you'll have the answer. Thank you very much.